Contemporary energy efficiency had two sets of requirements regarding low energy buildings with lowered energy consumption and passive buildings. Buildings with lowered energy consumptions are compared to the same buildings before any energy efficiency methods applied, while as passive buildings are buildings in which the inner microclimate is achieved without using active heating or cooling system. In other words, the house heats and cools itself only thanks to its organization and design, and that is why it is called passive. However, such houses still use energy for lighting, for domestic appliance, and for electronics. All the normative documents and requirements they set are based on the requirements for buildings with lowered energy consumption. Passive buildings are not an obligation when improving energy efficiency in built environment. If a passive house is equipped with additional systems for producing energy, such as photovoltaics and wind turbines, it can be a passive building with zero net energy balance and a passive building with positive net energy balance. Zero net energy balance means that the quantity of the amount of electricity the building produced thanks to its photovoltaics or wind turbines is the same amount the building used for its functioning. While the positive net energy balance means that the amount of energy the building produced is more than the amount of energy the building used. However, zero energy balance does not mean zero paying for energy because such buildings are usually connected to the global electricity web, and what energy was not used or stored in the building storage is sold to the national electricity web, and the national electricity company buys that amount on a certain price, and after that, if that building needs additional electricity and doesn't have it stored or produced, it is bought from the national electricity web on higher price than the price the building sold the unused amount of electricity. That is why such buildings still pay for the electricity they use when they need, but don't have and can't produce it. Buildings with positive net energy balance usually don't pay for electricity and also can deliver a certain amount of electricity to neighboring buildings. This illustration shows the difference between building without insulation, building with insufficient insulation, building with lowered energy consumption, and passive building. And the upper row shows the amount of energy needed for heating and cooling, and it's measured per square meter for year. And the way it lessens in every next building, and also is given the amount of carbon emissions every building produces per year, again on square based on square meter, and how it lessens according to the standard of the building. This table compares the requirements towards the characteristics of a building with lower energy consumption and passive buildings, such as the necessity of fuel for heating per square meter annually, um, and the necessity of liquid fuel or gas per square meter net surface of the building per year, which when the building is with lowered energy consumption, it is supposed to be under 48 kilowatt hours per square meter, whereas if the building is supposed to be passive, this requirement is under 15 kilowatt hour per square meter. Also, the requirements towards the characteristics of the surroundings elements of the building, such as walls, windows, roofs, and floors, and the amount of heat they let from inside out in cold seasons and from out to inside in hot seasons also differs several times. For example, if the building is supposed to be with lower energy consumption, its walls are required to let out no more than 0.5 watts per square meter Kelvin, whereas passive buildings are supposed to let no more 0.1 up to 0.15 watts per square meter Kelvin, which is 3 to 5 times difference. The requirements towards windows and doors also has significant difference. These are two examples of passive buildings built in Bulgaria. They are both set on the seaside. They use the orientation towards south. They use the specific of the surrounding land configuration, and of course they rely entirely on their design and the materials of their surrounding elements to heat and cool themselves. Especially that this building, the second example, it has south facade almost twice as surface bigger than the northern facade. And the largest surfaces, the largest glaze surfaces are turned towards the sun. An interesting solution are the inclined windows, which let the winter sun to enter the building and heat its floors and inner walls. Whereas in summer, when the sun is high in the sky, it has very great reflection of solar radiation back and does not allow it to enter the house and to overheat the rooms inside. This is um, the student competition called Solar Decathlon that takes place every second year in Europe and every second year in America. And it's a competition between students from universities and high schools for design, architecture, and civil engineering. And each team is comprised of both design architecture students and civil engineering students. And they have 10 days to design and to build by themselves living units, which after that are compared how energy efficiently they behave. Some solutions are purely passive, and others are passive with zero or even with positive energy balance, such as this unit here, which is covered with such amount of photovoltaics that it can deliver the necessary amount of energy to 5 more similar living units. So, if any interest, please do visit the official site of this competition. It has archive for several years back, and it's really inspiring and interesting.